Okay, so this huge packet that you have, I should say welcome to class. This huge packet that you have are the notes. It's like a note-taking guide. Well, it is a note-taking guide for the rest of the chapter for chapter 4. So we're just going to do 4.5 today. We'll do the other lessons on other days. And there's a hole punch thing on my desk or on that cart that you're welcome to use if you want to put it in your binder. I have more tomorrow, but yeah. So this is what we are learning. We kind of talked about this graphs of sine and cosine functions before from the unit circle, where kind of as it unwinded, it became like the wavy thing. It became the wavy thing. So our goal for this whole, well, for this part of the lesson, and I like these notes, they're good. So what you should learn from this part is how to sketch graphs of basic sine and cosine functions. And again, that's where sine is spelled with an E, meaning that that's the function. And then we abbreviate it in things with the sin looking thing. Okay, the important vocabulary for this is to know the amplitude. And so in order to do this, you would need, it is half the distance. So technically it is half the distance between the max and the min of a periodic function like this. So half the distance between the max and min, that's an and, min, for, it goes y equals a sine of x, or y equals a cosine of x. So notice instead of using theta, we're using x, and that's so we can use it, so we can graph it. And the fancy way that we use this mostly is the amplitude. The amplitude is equal to the absolute value of A. So even if it was negative, it's just still talking about how far up or down from the center it goes. And then the phase shift is the amount C divided by B, that's a C, C divided by B, so it basically, it goes a shift just like other things, it's a translation in this function, so in this graph. So y equals a sine of bx. So that's the original one. And then how it would shift, this is the original, or the transformation, would be y is equal to a sine of bx minus c. So I don't know if you remember when you're doing parabolas. So this will be just a little side note, and I'll do it in yellow. Little side note, when you're doing parabolas, I don't know if you remember, when we have it in vertex form, we would have x. Can you even see that? Okay, I don't think you can. I'm going to write it in a different color. So you would have x, you don't have to write this, x minus 3 squared plus 4. So this would move the parabola. So instead of going negative 3 or left 3, it would go right 3. And then the one on the outside is just normal, and that would be up 4. It's the same type of thing with these, where this number right here is going to tell you how far left or right. So this is the specific number. You would divide it by, if there was a number that was by the B, you would take that C and you would divide it by the B, and that would tell you. So remember that it's the opposite, says that since that is a minus C, so then this is a positive version of it, so it's opposite. Okay, and maybe this doesn't make a whole lot of sense to you. I just wanted to show you the vocabulary first, since there's a place for it, but it's going to come together. So we talked about taking the unit circle and basically unwinding it. And as you unwind it and put it across the graph, it's going to go up, like up and then down, and then up and then down, like that. It's going to be going like that for both of these, depending on where you start. So we usually talk about from 0 to 2 pi. 2 pi is one full circle on that unit circle. And the sine function and the cosine function do everything that they do on there. So, but for the sine function, the maximum, because if we're looking at that unit circle, this is my really rough sketch of the unit circle, the tallest or the biggest y is up there at 0, 1, right? And then this is 1, 0, so that's at nothing. And that's just going everything in between up to 1. And then it's going everything down to 0 again. And then down here would be 0, negative 1. So if you're thinking about that sign, looking at the y's, like the height of the y, like if I did this point, there's the y, there's the x. So up here, this value right there, that's the tallest one. And that angle right there is at pi halves. So at pi halves, so at the angle, so it goes angle, then the y, because that's the sine. Angle at pi halves, it's equal to 1. So on a normal sine function, that's the highest point, that's the maximum. The minimum point then is happening over here or over here. We're just going to talk about it over here. And we know that that angle right there is, that's going to be 0, and then its minimum is down here, and that angle down there is 3 pi halves. So its minimum point is at 3 pi halves, 3 pi halves, and at negative 1. So it's bouncing from the highest is 1, the lowest is negative 1, and so it's going up and down from 1 to negative 1. That would be the amplitude is 1, because it goes up to 1 and down to 1. So half that distance is 2, so half that distance is 1. Then it's going to have its intercepts where it crosses the x-axis. It'll have them right here, and then back to here as it goes around. So they're at 0, 0. And over here, so this is the xy. These points are xy, but when we're talking about, again, angle and the y, the angle right here is pi, and the y is 0. And then the other one happens back at 2 pi, 0. Which, remember, those are the same point on the unit circle, but as you're stretching it out and making it go across a thing, it happens again at 2 pi. So we always start with sine. Similarly, with cosine, we have maximum points. So remember, cosine is the x. So if we're looking here, the x is 1, or the tallest one right here. Here, and then back again if you're going around the circle over here again. So its maximum points are at 0, 1, and at 2 pi, 1. And then its minimum point is at negative 1, which is only over there. So it's at pi, negative 1. We're just looking at the x's. And then it's equal to 0 at those two places. So it's at pi halves. So that's the x right there, right? The x. And then the value, that's the angle, and then the value of the x is 0. And at 3 pi halves, 0. So sketching those, we're going from the unit circle to sketch those, and it goes like this. And I don't think you can see this, so we're going to have to draw in the x-axis and the y-axis. So we're just mostly going to do things over here. So over here, this is going to be for the sine. So this is going to be sine of x. And for sine of x, so it starts we're looking at the y's. Starting at 0 degrees, the y is 0. And then I think this is the easiest way. We're going to come over here and make this over here 2 pi. So then halfway between those will be pi. Halfway between those two will be pi halves. And halfway between those, 3 pi halves, or 1.5 pi. And then on the y-axis, I will go from +1 on the y-axis to -1. So again, this is the x, but the x is the angle, which, yeah, the x is the angle, and then the y is still the y like we had right here. So we'd start there at pi halves. We know at pi halves, it equals 1. At pi, it crosses. At 3 pi halves, it goes down to -1 and back to 2 pi. So it goes up, down, up, down. And you don't want to have it be a zigzag. You have to kind of make it curvy, like when you're graphing a parabola. So curvy touching up here, and curvy touching down there. And that's the main part we look at. It would keep on going forever and ever and ever, because we can keep on getting these same values as you keep on going around the unit circle more and more times. So that's the sine graph. Then the cosine graph, we kind of just do the same type of thing on it. But instead of the y-axis being what we know as the y's, it's going to be the x's from the unit circle. So again, x is equal to the angle on the unit circle. And then our y was really our x's, because that's the cosine. So this is the cosine of x. And I'm going to split it up like I did before. So 2 pi, pi, pi halves, 3 pi halves, and then 1 and -1. If we're thinking of our unit circle and the x's, when the angle is 0, the x is 1. When the angle is pi half, so straight up, it's equal to 0. At pi, it's equal to -1. At 3 pi halves, if we're looking here at 3 pi halves, the x is 0 again. To graph those. And then back at 2 pi, it's again equal to 1. So you don't want this to look like a big V. Again, you're going to try to make it curvy here, curvy there, and curvy back up to there. And then again, it would keep on going up and down, up and down, up and down. So those are the things, those are the basic graphs. So it is one repeat or one period in 2 pi, both of them. Cosine starts up, sine starts down.